In this class, we will discuss one or two problems on Venturimeter. In the earlier lecture, I have explained the concept of Venturimeter, principle behind it, and the discharge equation we have derived. So the problem states like this: a horizontal Venturimeter 200 mm by 100 mm is used to measure the flow of oil of specific gravity 0.8. The flow is 60 liters per second LPS. Find the deflection reading in mercury in the manometer by taking coefficient of discharge value CD value as 0.98. So last class I had derived the discharge equation. Here of course the discharge is given here. So let us see what are the data they have given. A horizontal venturimeter 200 mm by 100 mm means this 200 mm is the inlet diameter. First reading is the inlet diameter. Second reading is the throat diameter. So sometimes they give like this. So D1 is 200 mm, D2 is 100 mm. So I have written here 200 mm should be converted to meters because everything should be in SI units. Be careful. Pressure should be in Newton per meter square. Diameter should be in meters. Area should be in meter square. So those things discharge should be in meter cube per second. So D1 is 200 mm, so 0.2 meter. D2 is 100 mm, that is 0.1 meter. So you can calculate A1 and A2, that is the area at inlet and area at throat by using pi d1 square by 4 and pi d2 square by 4. You will get these values. So D1 is 0.2, D2 is 0.1. If you substitute and simplify, pi by 4 into 0.2 square will be 0.0314 meter square, and pi by 4 into 0.1 square will be 0.00785 meter square. So these are the areas. Now the discharge equation of Venturimeter is given by Q is equal to CD into A1 A2 divided by root of A1 square minus A2 square into root 2GH. Here you can observe that the discharge in the Venturimeter is given 60 liters per second. That is discharge. And of course here the liquid is oil of specific gravity 0.8. So it is not water. So that is another thing. So 60 liters per second, you have to convert to meter cube per second, divide 60 by 100,000, you are going to get 0.06. Because 1 meter cube is 1000 liters, we have to divide by 1000, so you get 0.06 meter cube per second. Now here in this formula, CD you know, Q actual you know, A1, A2 you know. So the unknown is H, capital H. So capital H, this is nothing but your Venturi head. Venturi head. I have explained about this in the earlier lecture. Venturi head. So only H is unknown. By substituting these values in this equation, we can get the value of H. So Q actual is 0.06 is equal to CD value he has given 0.98. Even if he has not given CD value, you can assume as 0.98. That is the standard value. You can assume it as 0.98 because the value varies from 0.9 to 0.98. As an ideal case, you can assume CD as 0.98 if not given also. So into, so A1 is 0.0314, A2 is 0.00785, divide by root of A1 square minus A2 square into root 2G into H to the power of half. That is root H can be taken as H to the power of half. Now on simplifying this, you get the value of H, Venturi head value as 2.83 meters. It will be in meters. Now I need the deflection in the mercury in the manometer, that the value of small h. So small h value is unknown. So you can refer the diagram here. So this is the inlet section, this is the throat section. Deflection of mercury level is small h here. So this is the mercury and oil is flowing here of specific gravity 0.8. So I will take the specific gravity of oil as S1 0.8 and specific gravity of mercury as S2, which is 13.6. This value you should know. Specific gravity of water is 1, specific gravity of mercury is 13.6. Now if you connect the manometer to the Venturimeter, so the deflection at the limb which is connected to inlet, so this is the inlet portion, this is the throat portion which is connected to the inlet. So the mercury level will be lower here because pressure is more here. So it will be higher here. This deflection we have to find out. We have derived one relationship between capital H and small h in the last class. That equation directly you can use here. So that equation is H is equal to capital H into S1 divided by S2 minus S1. So please note that this S1 is the specific gravity of flowing fluid. So here the flowing fluid is oil, so you have to take 0.8 for S1, and S2 is the specific gravity of manometer fluid. So manometer fluid is mercury here, so its value is S2 value is 13.6. Now if you substitute the values, H is 2.83 into 0.8 is S1 divided by 13.6 minus 0.8. If you simplify this, you will get the value in meters, so that you can convert it into millimeters. So you will get 0.177 meter or 177 millimeters of mercury. That is the deflection of the mercury in the manometer for this discharge. So you can see here in this problem, discharge is known, CD value he has given, diameters he has given, pressures, the diameters he has given. So only since discharge is known, directly you can use the discharge equation. Only unknown will be capital H, that is Venturi head. We can find out the capital H. Then by knowing the relationship between capital H, that is Venturi head, and small h, that is deflection in the mercury level in the manometer, we can calculate the value of small h. Of course, this is a very simple type of problem. Now the another problem is an examination problem. So you can see here, this is VTU January 2020, a horizontal venturimeter. This is also horizontal venturimeter with inlet diameter 25 centimeter and throat diameter 15 centimeters. That means D1 is 25 centimeter, D2 is 15 centimeter. That you can convert to meters, 0.25 and 0.15. Areas you can find out, A1 by pi D1 square by 4, pi D2 square by 4. So you get A1 as 0.0491, A2 as 0.0177 meter square respectively. Is used to measure the flow of water. So the liquid flowing is water. The pressure at throat he has given 30 centimeters of mercury vacuum. So the pressure at throat means it is P2 value. Pressure at throat. P1 is pressure at inlet, P2 is pressure at throat. So P2 is negative here. If he has given vacuum means it is negative gauge pressure. So minus 30 centimeters of mercury. So be careful here. He has given in centimeters of mercury. And at inlet it is 200 kPa. See the difference here. They have given the pressure values in different units. So P1 value is 200 kilopascal. Of course, it is gauge pressure. It is positive value. It is gauge pressure. So 200 kPa means 200 into 10 power 3 PA. That is Newton per meter square. So they are in different units. Taking CD as 0.98, find the discharge. So here QE is unknown. Q actual, of course, is unknown. So we have to find out that. So now let us see how we can solve the problem. So D1, D2 are given. So A1, A2 can find out. P1 is given. P2 is given as minus 30 centimeters of mercury. This should be converted to in terms of water. So minus 30 centimeters is same as minus 0.3 meter of mercury. So pressure in terms of mercury to be converted to pressure in terms of water just by multiplying by specific gravity of mercury. This value. This I have explained in the fluid pressure chapter. So you can refer that. So minus 0.3 into 13.6 is the specific gravity of mercury. So you will get minus 4.08 meters of water. So that means minus 30 centimeters of mercury is the same pressure as minus 4.08 meters of water. Now that once again this should be converted into Newton per meter square. So by using the equation P is equal to gamma h. So this is the equation which is used to convert pressure head. This is pressure head in terms of water. That should be converted to pressure intensity in terms of water just by multiplying by gamma value. So gamma of water is 9810. So this is H value, this is gamma value. So gamma into H gives the value of P in Newton per meter square. This is a very important conversion. You should be very careful here. This time, why he has given this is, there are two things here. One, you have to convert from mercury to water in terms of pressure head. Then that pressure head should be converted to intensity of pressure. Now, when you are applying the formula, you have to use this value and this value. So P1 is 210 power 3 Newton per meter square. P2 is minus 40,024.8 Newton per meter square. Now you can find out the value of H, that is the Venturi head. Capital H is given by P1 minus P2 by gamma W. Here flowing water is water. therefore you have to take it as gamma W. So substitute the value now. P1 is 210 power 3. Here minus into minus becomes plus. Very important. You can see here when they give vacuum pressure at this rotor, so it becomes minus into minus. It becomes plus 40,024.8 divided by gamma W is 9,010. If you simplify this, you will get 24.467 meters of water. So this is the value of Venturi head. Now once you get the value of Venturi head, that is capital H, you can find out the discharge using this same formula which I have written here. So here Q is the unknown here. So actual discharge we have to find out. So just write down that formula. Q is equal to CD into A1 A2 divided by root of A1 square minus A2 square into root 2GH. Now substitute all the values in this equation and simplify. So you will get the value of QA. Substituting all values. So Q actual is equal to actual discharge is equal to CD is 0.98. As I already told you, if they don't give, you can assume this value as 0.98 into A1 A2. A1 is 0.0491 into A2 is 0.0177 divided by square root of A1 square 0.0491 square minus 0.0177 square under root into root 2 into G is 9.81 into H. Of course, H is how much? 24.467. 24.467. This entire thing is under root. Now, if you simplify this entire thing in the RHS, you will be getting the value of Q directly in terms of metric cube per second, which is 2.479. So you can just check this value, 2.479 meter cube per second. So this is the discharge through the Venturimeter or through the pipe. So for this given data. So you can observe here that he has given the diameters at inlet and throat, he has given the pressures at inlet and throat. Only thing is pressure values he has given in different units. So when you are using the formula, we have to convert to the same units. So one value he has given in Newton per meter square, another value in centimeters of mercury, and also it is vacuum, that is negative pressure. So or sometimes they give suction. Suction also means vacuum only, negative pressure, minus we have to take. So here at the throat it is a negative pressure, at inlet it is positive pressure. Convert that mercury to water. Then once again water you will be getting in terms of meters. Meters should be converted to Newton per meter square as intensity. Then you use the formula for Venturi head. H is equal to P1 minus P2 by gamma W here, because water is the flowing fluid. Substitute, get the values of H in meters of water. 24.467 meters we are going to get. Then since H is known, you can directly use the discharge equation for the Venturimeter. All the values you substitute and simplify, you will get finally the actual discharge in the Venturimeter as 2.479 meter cube per second.